So it sounds like there's nothing. Okay. And just to remind you, let's do a quick reminder of what 11.6 was, because that's on the quiz. Did I put it up here? Let's make this official. Where'd that go? Monday. 11.6 and 11.7. Cool. So what's in 11.6?
Absolute convergence, ratio of test and root test.
Good. And what goes with absolute convergence? Another thing we define, conditional. Conditional. So if it's not absolutely convergent, it might be conditionally convergent. I like it. So we got absolute convergence. We got ratio test, which is going to become crazy big. It's the thing we use almost all the time. You're going to see that very soon.
I've already.
So ratio test. How does that work?
A to the n plus 1 divided by a to the n.
Yeah. No, a sub n.
Yeah.
Yeah. And then, yes.
And just to clarify, you could technically do the ratio of a sub n over a sub n minus 1.
Oh, sure. Yeah.
If you're like perfect.
As long as you got one element ratio with the element before. Sure. Yeah. And if this equals some L, when is this going to be convergent?
Less.
If L is less than 1, then this series converges. All right. If it equals 1, it's inconclusive. If it's greater than 1, it just straight up diverges. Right. And again, I really tried to show you how this is just geometric coming back. Geometric converges if R is less than 1. So if this ratio becomes some number, that number is the multiplier of this to become this. If that multiplier is less than 1, that's like geometric. That is a geometric sequence. Maybe series, right, when you put it all together. Okay. So that's ratio test. All right, so L equals 1 is inconclusive. Not 11, Jeff. L equals 1. Dan. Because we got to do more. It's inconclusive, so that means I have to do some other test. Maybe it's a p-series, maybe it's a direct comparison, maybe it's an interval test, right? Something. And if L is greater than 1, it's just straight up divergent. So remember, we did an example last time where somebody said, what if it was conditionally convergent? And what did we figure out? I showed one example, but you should understand it's basically almost that if it's possibly conditional, then L will be 1. Yeah. Because then it's not absolutely convergent, but it's also not divergent. So that would fall here. Okay, like it, maybe.
That's a hard and fast rule, right? Basically, if L equals 1, it's
Yeah,
probably conditional.
because if L is less than 1, it's absolutely convergent.
Yeah.
And if L is greater than 1, it's divergent. So if something is conditionally but not absolutely, and you do the ratio test, it's got to come out to be 1 here. Okay. Yes?
Okay, so if it's inconclusive, and it's, so that means it's not absolutely, or it does not diverge.
But it could be conditional.
Is that?
And actually, be really
Another
careful.
option would
I want to
be-
be really careful. If it is conditionally convergent, L would be 1. Is everybody with me? I did not just say if L is 1, then it's conditionally convergent, did I?
You can still diverge.
It could still diverge. It could still be absolutely convergent. It just, the ratio test just can't tell. You have to use a different test. Okay, maybe. So this is what I meant when I didn't really focus on it a ton, but I did make a point about talking about logic. If then, right? This is so often misinterpreted, and the more theorems you see, the more often they're if then, and people just think about the backwards, oh shit, and they get in trouble. Okay. Ratio test, and of course the root test had very similar results interpretation, but the root test was literally just doing what?
Just taking the square root.
Taking the square root, and then
Or
nth root.
the nth root.
Yeah, nth root. And the same idea, A equals L, and then the same exact interpretation.
So if it was like, if an was to the 2nth power, you would leave the 2 there for talking about bottom, and then just pull out the unit, right?
Alright, let me make sure. So, give me an example problem.
So like if it was like,
If it was like n to the 2n over 3 to the.
That I would not use the nth root on, because it's got an n that's not
or no,
raised
if
to.
it was like 7 to the 2n over like 5 to the 2n, would you leave the 2's there and then do the root
Oh.
test and pull out the
Well,
n?
no, the first thing I would do is I'd figure out this is actually 49 to the n and 25
Yeah.
to the n.
But
Then you have geometric.
could you also do the
What-
root test?
Yeah, of course, of course.
Okay,
What
Yeah,
if
yeah,
you-
yeah.
and just leave
It
the
would
What
two.
still
if
have
it
to be
was
7 squared and 5 squared, yeah.
What if it was like 7n on the top and like 3n on the bottom? It's like different n's, so where you can't really do geometric.
Oh, no, okay. I love this, okay, you ready? Alright, I know what you're saying. So if it was like, I don't know what you just said, but let's say 3 to the 5n, right? Over 5 to the 3n, how's that, or not even, let's just make it, I don't know, 4 to the 3n, yes?
Yeah.
Yes?
Uh-huh.
So, sorry.
Oh, because you can.
What's 3 to the 5th power, right? Yeah, what's 3 to the 4th power? 81, and then times 3, 243. So this is actually 243 to the n over 4 cubed, which you don't need, which again, the root test would work, but we don't need it because we have a shortcut for this. This is just straight up
Geometric.
geometric.
Yeah.
And this is obviously bigger than 1, the r, right? So it's when things are close to being geometric, or they have a geometric heart. Oh, it sounds different. There's a geometric piece to it, but there's other shit around it. That's when the root test or the ratio test can kind of get at that. It's not quite perfectly geometric, but in the long run, it becomes closer and closer to geometric. Then it depends on, well, is that number I'm multiplying by greater than 1, less than 1? Then I can tell. I really want this to make sense. It's just geometric, both the ratio and the root. They are actually just talking about things that aren't quite geometric, but they're close enough to geometric that I can look at them like this. Okay, maybe. You guys with me? So like the root test, I mean, if I take the nth root of this is obviously 243 over 64 multiplied by itself forever and ever and ever, right? Because the nth root, yeah, of this, those cancel and you get that. And that's greater than 1, so it diverges. Right? So if I had something that had some extra bit to it, I could still do the root test and it would still mean the same thing. I'm still looking to see what is that multiple that's happening forever. Maybe? Okay. Okay. That's 11.6. And what's 11.7? Everything. Okay. Meaning P-series, geometric series, integral test, root test, ratio test, just everything, right? So your task is to really familiarize yourself really well with each individual process, and then the next level is how do you tell when to use which, right? Okay, maybe. Anything else specific before we, or general? Yes.
Like the identities that are like, the integral of secant is the natural log absolute value of secant x plus tan x. Do we need to know those?
No, I'll just give you those.
Okay.
Yeah, if I don't have them memorized, I don't see myself memorizing that. I probably should, but I just don't want to. So I'm not gonna I never make you memorize something I don't personally have memorized. So it's probably a good idea to memorize those. I just don't want to. So I'm not gonna force you to. Hopefully you understand that. Okay, if there's nothing else, we're gonna get into some really cool shit. For a change. Okay. No, I don't care. So, can you think back to when you were algebra students first learning about quadratic formulas, right? Quadratic equations. And you're sitting there like, what the shit good is this shit? Who needs this, right? And now you're looking back going, holy crap. So when you first learn something, what we normally do is we talk about what does it look like, what do you do with it, how does it work, how do you graph it, all this kind of stuff. So 11.8 is going to lay the groundwork for something that won't be immediately obvious what's so important about it, just to let you know. But then we're immediately going to do some amazing freaking shit with it, right? So we just got to lay the groundwork. We just got to talk about the basic idea. So 11.8 is just laying the groundwork. So let me ask you this. If I gave you, all right, we're going to look at something. I've decided to do this. So if I gave you this, we've never really looked at something like this. There was one problem that came close. It was the problem that had a K in it. So they could have just put an X in it and said, when is this converge or when, right? They could have just put an X in it. What is what kind of series is this? This is a definite, if X is a constant, which is what it is, X is some number, what kind of series would this end up being? Geometric. So we actually don't have to do any work. We already know definitionally when this will converge. What must be true about X?
Less than 1.
Yeah, so this has got to be less than 1 to converge. What happens if X, so that means that X has got to be between -1 and 1, correct? What happens when X is -1? Why? Yeah, go ahead. Think about it.
Periodically cycles.
So if X is -1, then the sum, the first element would be -1, then it would be plus, so now it's 0. Now it's -1. Now it's 0. Now it's -1. Oh God, right? So that would be oscillatory. It wouldn't agree on something. And if I put a 1 in there, well, that's even worse. If I put a 1 in here, what does that do?
1 forever.
Goes to infinity. It diverges. It's 1 plus 1 plus 1 plus 1 to infinity. So that's going to be infinity. That's the most basic kind of definition of infinity. So start counting. 1, 2, 3, 4. Right? Okay. Keep doing that. Okay. This is now this seems very uninteresting. So here's what this is missing to be more interesting. So this by itself truly is just a geometric series, and we know what we have to put in here to make it converge. So if somebody came along and said, what if X is 11/10? What kind of series would that create? Divergent geometric series, 11. Okay. So the one thing I can throw in here to make this much more interesting than you even know at the moment, it's one little thing. So to make it a full, what we call power series. So it's not an exponential series because the variable's not in the power. It's a power series like x squared, x cubed is x to a power. So we sat around, mathematicians were like, what are we going to call this thing with the power? So we're going, well, power series. So a power series looks like this. Okay. What the shit is that? All right. So that's a good question. Pretty sure you wouldn't put it that way. So this is what we saw before. Same thing as before. You can make x7, you can make x.3, you can make xe, whatever the shit, right? You can talk about what that creates. But now I'm allowing for something we've also already seen. So for example, let me give an example of a very specific power series. Can somebody tell me what Cn is?
And
Yes, so the letter C, the word C, good job, Jeff. The letter C, you can think of it as standing for coefficient. And why does it have a little subscript n? Because isn't the first coefficient different from the second coefficient, different from the third, right? What's the first coefficient? 1. What's the second coefficient?
2.
What's the third coefficient? 6. Good, blah, 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 blah. Okay, so everybody see that? So don't let that be a mystery. That's just the coefficient, but it could be a function of n. So as I put n's in it, it just becomes numbers, and they're just coefficients of x to a power. Okay. So what I really get here then, what are the elements of this? 1x to the first plus
2x squared
2x squared plus,
plus 6x cubed.
right? Whatever. Okay. So now the question is, are there any values of x that would save this, right? On the surface of it, what does this do? So it seems like, well, let me say this. Maybe there's an x value that's so tiny that it will make it converge. Are you guys understanding what's happening right now? So the reason that this is geometric, this has a single interpretation for when it converges. What is Cn here? Careful.
One.
Coefficient's always 1, right? So Cn is 1. Not a very interesting series. Cn could be any freaking thing. It could be n factorial. It could be n to the n. It could be n to the n divided by n plus 1 to the n plus 1. It could be whatever the shit it wants to be. Any function of n. And any value of n makes it a number. So it's coefficients. Those are what makes things much more interesting, right? You just make it 1, it's just a freaking geometric, like we've seen before. Are you guys with me? And of course, before, we called this r, right? We didn't call it x, but it was just something I could throw a number into, so why not call it x? Hold on, okay. So, let's look at this thing. Okay. Let's do more than look at it. How do I test that for convergence? Somebody we know how to do this. Should I use root test? Is
No.
root test a good idea?
No.
Ratio.
Root test sucks here, yes? I don't know if the nth root of n factorial. No, don't do that, Jeff. Gotta think of a bonus question now that has something to do with it. Okay.
No.
It's bonus. What do you want from me? Make bonus whatever you want. So, can you guys just take a minute and set up what the ratio test would look like for this? Just set it up. It's just a ratio test. We've done ratio tests. I think a lot of you guys might even like ratio test for the most part. Maybe some problems, not so much. Yeah. That makes me happy because I love ratio test.
You multiply by the reciprocal?
Yep.
So just one over.
So it's basically, it's just, in this
You're
case,
just
it's
dividing.
not
Yeah,
fractional,
you're
so it's
just-
just gonna end up
Yeah, you're just
on the bottom, yeah. There's no fraction here, right? So let me catch up to you guys. Here's where the absolute value is gonna be crazy important. It's always important, to be honest, but oh. Okay. How does that simplify? This isn't that.
N plus 1 to the times x.
Yeah. Xn.
Yeah, you can pull out an n plus 1 here. Let me just show a few steps. How can I break this up?
X to the n times x to the
Good, I like it. And then of course these guys are just sitting around and they just kill that.
die.
So there's no limit. Well, no, it's
We don't know what x is.
the limit as
So
it
this
goes
is
to
the
infinity.
limit.
Oh,
as
oh,
n
I see what-
goes
I
to
see what you're
infinity
asking.
of n plus 1 times x. And what's that gotta be less than in order to,
One.
it's gotta be less than 1, but what is this limit? As n gets really big.
It's gonna be infinity.
It's infinity, except for one value of, any value of x I plug in here, isn't the answer gonna be infinity?
Mhm.
Or negative infinity, if I make x negative 3 or something, are you guys with me? Any value of x I use, except for 1.
Zero.
Yeah.
Zero.
If I make x
Or s.
0, isn't this a silly freaking, if I make x 0, what am I doing? I'm adding up
Zero.
0 to itself
Infinity.
forever. Of course, that's kind of, we often call that the trivial solution, right? What series will add up that doesn't go to infinity? Well, add 0. So that's so if your limit goes to infinity, that means there's only one value of x that can save this, and that is 0. Okay. Equals infinity, so only x equals 0 makes it converge.
Is that an answer we're gonna be seeing a lot of?
That is an answer you will see. I don't know, a lot of.
You'll see a lot of ones on bottom.
Well, in this case, I'm going to show you. Well, okay. So this is not a good enough problem to show you the full thing, but just this is a nice little step into it. Because there's nothing hidden here. It's very blatantly obvious this thing is going to go crazy. From the beginning, you should have realized that's just going to go crazy. It doesn't matter how small I make x. That's going insane. There's just no way. Okay, maybe. And this kind of proves that. Only x equal to 0. That's gonna always be a possible answer. Right? The thing that makes this 0, notice how I said that. So depending on what's in here, it might not be 0. It might be x minus a or something. Okay. Let's try one that has a more interesting outcome. Let's see, I don't know. I'll get out of there limit. I'm not doing it yet. Let's say, sure. So let me ask you 2 questions. Is this a power series? Because it's in the form c sub n times x to the n. Okay, I like it. So you gotta be careful. You can't use power rule ideas when something's not really a power series kind of thing. What's Cn?
N squared minus 2
Yeah.
over 2x.
You see that thing? All right. Okay. So let's see what happens here. Let's do. So what are we gonna do?
Ratio test.
Ratio test. All right. This is big sign. Okay. See the height. Let's see. So it'll be. Let's do it like this. N squared. Got it. N plus 1 squared minus 2 over 2 n plus 1 squared plus 5 n plus 1 x to the n. Let's put x to the n on top. Times this, right? The reciprocal. Oh, Jeff. X to the n plus 1. So this is putting all the n's, making them n plus 1s, right? Times, let's see, 2n squared plus 5n over n squared minus 2 times x to the n. All right. So the x's we can do our normal stuff with, right? So I'm gonna put, let's see. I get, n plus 1 squared minus 2 times 2n squared plus 5n over 2n plus 1 squared plus 5n plus 1 times n squared minus 2. And then I could just put, no, check, x. Is everybody cool with that? So here the nx's cancel, so I'm left with 1x on top, right? Okay, let's see if you guys can see what's most important here. What is the limit as n goes to infinity of this?
1? Wait, hold on.
What will the degree up here be? The top,
We have
highest
2
degree
n.
will be-
We have 2 n
It'll
squared.
be
plus
zero.
1. Yeah.
It'll be 0.
So it's 2n to the 4th and other shit. That doesn't
Oh,
matter, does
sure.
it? I just care about the highest degree, don't I? This is what you need to realize. Don't waste time. Good Lord, don't foil this shit out. This would be n squared times 2n squared. It's 4n to the 4th plus other lower degree shit that doesn't mean anything to us. Sorry. Get away from it. And on the bottom I get 2n squared times n squared is 2n to the 4th plus other stuff, right? So nothing higher than a fourth degree. Do you guys see that?
So it's
If you
one.
don't, then you have to multiply all that out, but please do God. So what is the limit of 200 to the fourth plus stuff over 200 to the fourth plus stuff?
1.
1.
That's really inconclusive.
No. Okay, now here's what I really want you to understand. The results do not change. What must be true about the answer we got to make this converge? Again, what's ratio test? When I get an answer, it must be what?
Less than 0.
Less
Less
than
than 1.
Less than 1. Therefore,
Any value.
and what
less than
values
1.
of x make that true from -1 to 1, right?
Yeah.
All right, now here's where things get really interesting. All right. And you're like, now a warning? No. Here's where things get interesting. Okay. Let me get that reference. Now a warning? No. So, let me make sure everybody's with me. What does this series do for any x value I put in that's between -1 and 1? It converges. Because those are the values of x that make the results of the ratio test less than 1. Yes? This is what's new right there. We're not used to getting something that's not really a number, so we can't just look at it. No, you say less than 1, and then the answer is every value that makes that true because it converges when the result is less than 1. I like it. Okay, here's the kicker. Here's the thing. I need to test the endpoints to see what happens at them. Because I don't know if the answer is going to be this, the answer could be this, the answer could be this, the answer could be this. Right now it could be any of those. I know that -1 to 1 works. Everything between. What happens at the endpoints? Oh. If you guys are with me now. Okay.
If x is 1, doesn't it diverge?
Well, let's
Well,
see.
it's inconclusive.
It depends. No. Wait. No, you can't look here and get your answer. We put these how do I evaluate this given a value of x? Don't I just put it in?
Yeah.
Let's do it. What values of x do I need to look at? -1 and 1. So what series do I get if x is -1? And then we have to look at it. And then maybe do some stuff to it. Right. Let me stop for a minute. It is still ratio test. It is still ratio test. The thing we're not used to, we're used to getting like 0.7, okay, that's less than worth. 3/5, okay, that's less than worth. 7/3, well, that's greater than 1, it diverges. We're used to getting a number and then we can just tell. Well, now we're getting some function of x. We can see when is that less than 1, that's the answers, that's where it converges. But you just said something really good. If it equals 1, the ratio test is inconclusive. Where is this thing equal to 1? At the endpoints. So we have to use a different test. We got to plug those in, use a different test. Is everybody with me so far, roughly? Okay. I'm going to take this away because we don't need it anymore. We've got the answer, we just got to look at the endpoints. Yes, sir.
I'm a little confused as what the difference is between like the ratio test and what we're doing.
Nothing. And this is what I just said, right? I
Okay.
just tried to make you realize that this is the ratio test. Nothing is different.
So,
The only difference is we're used to getting a number here and just seeing if it's less than or greater than 1. Now I get a function of x that will be less than 1 for some values of x. Those are the answers.
so for power series, you can use different tests. It's just the result is different than what we're used to, or is it specific to ratio test?
We're done with most of this problem. We know that every number between -1 and 1 makes this convergent. That's a lot. We know a ton of shit. There's only 2 things we don't know. What happens at -1 and 1? That's the only things we don't know because that's the only place the ratio test fails. Because if x is 1 or -1, isn't the answer equal to 1? Ratio test inconclusive. So I really want this to make sense. You have to put the endpoints in one at a time and evaluate the series because that's the ratio test can't tell you shit about the endpoints because they're the ones that make this equal 1. Maybe. Yes?
So, when you get like half, so I will not need to do extra stuff for the endpoints because then it will be just
You
half.
will. There could be situations where this is not dependent on x.
Oh,
In which case the answer is all real numbers, right? If this comes out to be 1/2, is that dependent on x? No. And what does 1/2 mean? If I get that result from the ratio test, if I get 1/2, what does that mean? Converges. Converges no matter what x is. Do you understand? No matter what I make x in that case, it will converge. We'll see an example like that. For the one we got, we know that those values work. -1 to 1, we just don't know if we're going to include one or either or neither. Right? Okay. So what does the series look like if I use -1 for x? Oh. So all I'm doing is putting a -1 in. So what does it look like? So if I put a -1 right here, doesn't it look like? What is it? What is it? Yeah, alternating series. Well, what's the limit have to be
0.
of this? And what is the limit of this?
1/2.
So the limit of this, blah, 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 equals 1/2, not 0. So is this convergent? Nope. And of course, if I let x be 1, then it's even worse. If x is 1, then this is just 1. Right? So let me leave this up here. So that's if x is -1, and if x is 1, is that? That's adding 1/2 forever, basically, eventually.
Which is divergent.
Divergent. So the limit is not 0, it's 1/2, therefore it's divergent no matter what. So the correct answer is this one. The endpoints make it diverge. I love you guys. Some of you guys have given up on me already, I can tell. Some of you guys have gone to sleep. Shit. It's just ratio test. We just have we could get an answer that's dependent on x. Let's do another one. Let me see. Let me get one that's a good one. Give me a good one. Not you yet. You're too freaky. Go away. Yeah, you're pretty good. Yeah, you're pretty good. All right. Okay. Oh, this is gonna be fun. All right.
I don't love that.
All right. First off, is this a power series?
Yeah.
Yeah.
Why?
Is
Because
there-
it's in the
Yes.
form of -3 to the n over square root of n plus 1 times x to the n.
Yeah, so there's a Cn and there's an x to the n. I love it. Yes.
So with power series, does it have to be x to the n, or can it be like a polynomial to the n?
Oh, okay, so we're going to expand the idea a bit, but
Yeah.
then we're not gonna call those a power series officially.
Okay.
It has to be x to the n. Sort of like, when can I use the power rule directly is if it's x squared or x cubed. If it was sine of x squared, then I'd have to use chain rule in there, right?
Okay.
So it's not like purely power then, it's a
Yeah.
mixture, yeah. Okay. So you just start doing ratio test, right? There could, well, there could be, there very easily could be situations, in fact, we'll do that next, where you don't use ratio test. So we'll do that one next. And then I want to do one, Kelly, you gotta remind me what yours, wasn't there something you came up with? I'm gonna come up with an example where, I can't remember what you were saying now. Shoot. If you think about limit.
Yeah.
So, go ahead and set that up, I'll catch up to you. Set up the ratio, and just remember, we're taking the absolute value, so you don't have to bring the negative along, you just put 3 to the n plus 1 and all that kind of stuff, right? The negative you can sort of leave out, because we're taking the absolute value of it. Not too bad, right? Just replacing n with n plus 1. And again, we know by now that if you see this kind of thing, and you put in n plus 1 in, you don't just get this, right? You get 4n plus 4 actually, because if you replace n with n plus 1, you gotta distribute blah blah. So be careful. Don't just put plus 1s everywhere, that doesn't quite make it work. So again, this should be
3 times.
like second nature now.
Yeah.
N of these will cancel, leaving you with 1. N of these will cancel, leaving you with 1. So on the top I got 3x, and then this I got a ratio of these. But what's that limit as n goes to infinity?
1.
Yeah, aren't these the same degree? We can kind of extend that idea.
Yeah.
Same degree, ratio of coefficients, 1.
So less than 1/3 greater than 1/3.
Yeah, let's catch up there. So the result of the ratio test must be less than 1 to converge.
Right.
And then you solve for absolute value of x, right? You divide by 3. Is that cool? You guys see that?
Very good.
So this is a little more interesting. This is a result that's not like geometric, right? It's got a little bit of a modifier on it. So now x can be less than 1/3. So what's the actual range?
Negative 1/3.
And 1/3.
Now we have to check the endpoints.
So again?
We have to check the endpoints.
Exactly. Let me ask you a question before we do that though. Do you see how there's a center? Isn't there a center of the
Zero.
interval, right? The center would be
0.
0.
Yeah.
What would you call the radius then? So the radius of a circle goes from the center out. So the center is 0, what's the radius?
1/3.
1/3. So the radius
Oh.
of convergence,
I don't like that.
what? I don't know, is 1/3.
It's a one
Oh,
piece
that's it,
circle.
okay.
Huh?
It's a one piece circle.
Yeah.
I thought you were gonna make it weird. Whenever you say stuff like that, it gets weird.
Okay, alright. Well, weird stuff's coming.
I bet.
You will not be disappointed. Alright, so now, like you said, you have to see what kind of series results from the endpoints, because this would be inconclusive at negative 1/3, because if I make x one of these, then this would be 1. Inconclusive. Shit, so let's take a look. What do the series look like? So if x is negative 1/3, let's see what this series looks like. Most intriguing, right?
Negative 1/3 definitely doesn't work.
Algebraically, since those are raised to the same power, you can combine them?
Yeah, I got n of these, n of those. So what's negative 3 times negative 1/3?
Negative
positive
1 or 1.
It's 1. 1 to the n is
One.
1, so this becomes.
Yeah, negative 1/3 does not
That's
work.
just a piece here.
And we're to the point now where you don't have to do direct comparison. This is basically p series, where p is what?
1/2.
Yeah, so say p is 1/2, which is less than 1, which means this
Divergence.
diverges. I should say less than or equal to 1, but same thing. So I know the interval will not include this. So you guys should already know what's going to happen when I put a positive 1/3 in. So everybody got this here? I'm going to be very lazy just because. So if I make this positive 1/3, what do I get now? Negative 3 times 1/3 is
Negative 1.
negative 1. What kind of series is that?
Alternating.
Alternating. Right? What do you need for alternating series?
Limits to 0. And it's decreasing.
Yeah, the limit is obviously 0, so this is 1. Or if you just said this, I will leave you alone. Right? That's painfully obvious that that limit is 0. What else has to be checked?
Whether it's decreasing.
Ah.
It is decreasing.
Yeah.
So I have n plus 1 to the negative 1/2. So if I look at x plus 1 to the negative 1/2 derivative, I get negative 1/2 x plus 1 to the, that's right kids, negative 3/2. x plus 1, where x starts at 1, is always positive. So therefore, this is always negative, which means it's decreasing. So we got limit 0, it's decreasing, and the only thing we have left is, yeah, the part that doesn't have the alternating is positive, and of course that is greater than 0 for n greater than, well, for all n really, but for n greater than or equal to 1 for sure, right? Let me stop for a moment. I'm curious now. Yeah, it's true. I should do that. Yeah. Okay. So what does that mean?
Square bracket on the 1/3.
Yes! So the
Round.
actual interval of convergence. Oh shit. Sorry. The ring of power. The interval of convergence is don't include negative 1/3, but do include 1/3. Kabam!
Is that any good, by the way?
Huh?
Ring of Power.
The ring of power, what about it?
Is it good?
I'm not even watching it.
Oh, okay.
I think I'm gonna watch it the moment I get some time. Yes.
Just a quick clarification, for the, that step, yeah, the reason you took out the -3 is just because it's an absolute, right?
Yes.
Okay.
Yes.
Just wanted to make sure.
There's no reason to kind of try to bring it along and keep track of it when I'm taking the absolute value anyway. Okay, cool. But now you see, earlier it didn't make sense to keep the absolute value then because you sort of eliminated the negative component. But now we have this x input that itself could be negative. So now the absolute value, now you realize it's gotta be there. Even if you take the negative away, this could be negative. In fact, we saw, yep, there's some negative values that work for x. Okay. So the absolute value has to be there. How you guys feeling? Yes?
Just to double check, a bracket means that it includes it and parentheses means up to it.
Yes, so watch this. You guys watch Dragon Ball?
Yes.
Alright, so like whenever I teach graphing these things, I'm always like, people sometimes have trouble with which direction these go. So then I always talk about like, Kamehameha, right? So then the shape, there it is, ah! And there's cell over here, bah! Anyway, sorry. Very sorry. Okay.
No, that was
Your
good.
real question though is, do you remember back in the day, we actually put like an open circle
Yeah.
and a closed circle, right? So what's part of an open circle? Parenthesis, right? So not include open circle, cut in half parenthesis. And didn't this mean to include? Look at the letter I.
Okay, that's a stretch.
No, it isn't. Look at that. That's too good. I mean, give me a break. Does that make sense? So that's what I always show my students when I'm
Just
teaching.
remember, this is this, and that's the other one.
Pretty much. Yeah. As long as you know what one is, you know what the other one is. Yes. But I like that. That's cool, right? No?
Yeah.
Anyway. Okay. So this is just ratio test. It's just at the end, we got a little more to do because it's got this unknown component to it. And I really want you to understand this. I could pick a number and put it in there, and then make a series for you to evaluate. So I'm just like, well, what numbers could I just put there? What kind of problem could I make if I wanted the answer to be convergent? That's really what we're doing. So if I put a 1/4 there, would it converge?
Yeah.
Oh shit! Yes,
Yes.
because 1/4 is less than 1/3. Yes. Okay. Right. You with me? Okay. Maybe. Okay. All right. So let's try. Oh shit! I should have wrote these down. There was one I wanted to do. Somebody remember? Somebody got this here?
Yeah.
And I think I saw
You
erased.
said you wanted to do one that Kelly was showing?
Yes. I don't know if you remember what you were saying. No?
I asked about like if the limit turns out to be like less than one, if we need to find.
Oh,
the
yeah, yeah,
endpoints.
where the x cancels. Right? Okay. Let's do that. Let's do one where the x cancels. Let me think. Shoot. You can do it, Jeff. Come on. Alright, let me see if I can find one real quick.
I actually just watched that movie on Monday.
Oh, really?
Yeah.
Come on. Let me think.
It's a classic. That would be classic.
Where would one be? Alright, let me cheat a little bit.
What? Oh, I'm not very good.
Okay, 11. Let's cheat just a little bit. There we go. Alright. Why didn't I see you earlier? Oh, there, of course. Okay, good. So. Yeah, this is a good one. In fact, let me start being. Wait, what does that start at? 1. Okay, that's fine. All right, let's do this, and then I'm going to modify the problem as they've written it a little bit. Okay, yeah, well, this is good. This is going to accomplish two things at once. I love it. Maybe. Yes, it will. Okay, I love it. Oh, it's kicked so much ass. So, I made a big deal about when we do ratio test on these, it's just ratio test, the results are the same, I just have this unknown, so forth. Is there a better thing to use on this one besides ratio test?
Root test?
Yeah,
Root
root
test. All right, so what does root test say?
Just root to the end. Power.
And root, the absolute value of this shit, right? Okay, I like it. So what happens here, of course? And why did we see this is a good candidate? Because every piece in here is raised to the nth power. So of course the nth root is an awesome thing to do, right? So the root test is much less used because it requires everything to be raised to an nth power. Or there's other things you can use it with that's just kind of gross. These kill each other. And what is the limit as n goes to infinity of x over n?
0.
0. When is that less than 1?
All the time.
All the time. Always. So is there only certain values of x that make it work?
No.
We just said it always works, right? Is the result we got dependent on x? Is the result we got dependent on x? No. So what can x be?
All real numbers.
Anything. So the interval of convergence, open brackets, negative effect.
What's that other notation, like with the R?
Sure. All real numbers. It's like R grew an extra spot. Yes. I like it. It's been augmented.
Yeah.
Faster.
Weaker, so for some reason. So yeah. Faster, strong. I'm not weaker. Sorry. What's the radius of convergence?
Infinity? Is that a thing?
Yes.
Yeah. Okay.
Infinite radius.
Oh, so the reason.
It's like a circle whose
It just-
edge you can never get to.
It's like if the Earth was flat, but it's not. So
What?
you never.
What do you mean
it's
edge? What do you mean if it's not flat?
It's like people who think the Earth is flat. They just keep going.
You realize there's still people out there. That think this.
The Earth is flat.
Didn't know there were so many sheep in this room.
Oh, yes.
That's what I'm saying.
Alright. So this makes sense? So the beautiful thing about this is you're just identifying,
It's like an infinite
you're just doing a limit. The limits are almost always gonna be relatively straightforward. And then the result, if you get a number here, like 1/2 or something that's less than 1, it's always works, right? What if you get like 2?
It's always divergent.
There's always divergent. Yeah. But you're not going to get that because if you make x 0, that can always be an answer. So you always have at least that answer. So we've seen 3 things that can happen, I think, at this point. So what 3 things could happen? So given some power series, what kind of convergences can we get? We can either get, in fact, let me make this, well, let's see. All right, before I do this, let me do one more example. I'm gonna backtrack a second. And then I'll just give you the handout that's got all this shit I was gonna write up here anyway. Let's look at this real quick.
That's what I was about to ask.
Huh?
That's exactly what I was about to ask.
Oh, okay. What do you got, Jeff?
N plus something.
Sure. Let's see what happens here. Yes.
Kind of a, like unrelated question. With the absolute, I thought with the ratio test, it's only proves absolute convergence. So could there still be conditional convergence with like a Taylor series or a?
Wait. Start over again.
So I thought the ratio test only tests for like absolute convergence. Is there still?
Totally. When we check the endpoints,
Yeah.
we're not doing a ratio test.
Okay.
Like we just did, we had an alternating series
So
test.
that's when we're ruling out conditional, basically.
So that one worked, the 1/3,
Yeah.
that was conditionally convergent there.
Okay.
Yeah, which means the series is convergent. I want you to understand. I've always had a problem, I don't know, real quick side note. Conditionally convergent is really kind of mean, right? Because it's the series. The series has a -1 in it. We really should just call it convergent. And then like the absolute convergence is like, oh, it's even better. If I took the -1 out, it still converges. It's like it didn't need it. But we call it conditionally convergent. It makes it sound like, oh, you gotta do something to make it. No, the thing you gotta do is not change it. Do you understand? Conditional convergence means, oh, if you don't take an absolute value, then the series converges. Then you're like, well, then the series converges. I don't know if you guys understand what I'm saying. No?
It's discrimination.
A little bit. Right. Who speaks for the variables and the numbers? I don't like this one, by the way.
It's too easy.
Yeah, it's too easy.
Make it N plus 1.
Yeah,
Alright,
it
N
is.
plus 1.
I've already done all the
Let me think. What's a good thing to put here? I don't want to use n to the n again. Nah.
It's all real numbers.
Nah.
N plus 1 is
Well,
a
alright. Alright, let's do this. We'll just do the same one we just did, but I just want to show you. It's basically the same thing we just did, correct? Yep. So I'll be okay with this eventually. Eventually.
That's fantastic.
So if you do ratio test, that's not a bad idea to redo this one because it's got this weird thing. So now this is still a power series. It's just been shifted by 1, right? So for example, if I had to take this guy's derivative, do I need a chain rule or anything? No. Isn't this still a power rule? Yes. 3 comes down, x minus 1 squared, then the inside's just 1, right? I don't know if you guys are understanding. I'm trying to show you why we call this power series, because they're kind of related to power rule. What kind of things would power rule apply to? Linear in x to a power, right? Okay. So, I can use the root test again. Oh, this is silly.
Yeah.
Yeah.
The same thing as the last one.
Yeah. Well, no, well, yeah, this is, okay. Okay. Real quick. Equals x minus 1 over n, limit, and so this is 0 again. Okay.
Yeah,
Okay.
all
Not
real
interested.
numbers.
So, come on, Jeff, you can do better. So this is, of course, everybody with me? That's all real numbers again.
Yeah.
Good job, Jeff. Okay. So let's go ahead and do what I was about to do. Yeah. Just at least be a little more interesting. In fact, I could do, sure, here, this will be a lot more interesting. Let's put a 4 to the end. Yay! Okay, I feel a little better.
Oh, okay.
Put a 4 to the end there if you didn't notice that. Okay. So now apply the ratio test. So it'll be 4 to the n plus 1 times x minus 1 to the n plus 1 over n plus 1 factorial times n factorial over n minus 1 to the n. Okay. So the same old stuff happens, right? I lose n fours, so I got one left. I lose n of these, so I got one of them left. So far I got 4, x minus 1. And then here,
You're gonna take that and
I
factor
can
out.
shuck off one of those. So it's over n plus 1. What did I lose? Did I lose something? This didn't do what I wanted it to either, I think. Oh, shoot. Jeff!
You tried.
Oh, yeah, I know what I should have done.
Alright.
So this one again, oh my god. Okay, alright. Let me try one more time. Don't give up on me. Don't give up on me. Real quick, what's the answer to this one also?
Oh, we don't know.
All real numbers, right? Infinite radius. Okay. Cut to like an hour later. This time I'm gonna get it. Just use it for the book.
I honestly don't know what you're going after anymore. You like,
I got it now. I'm gonna do something
It's gonna be one more.
Alright, here we go.
And subtract stuff.
You got this.
A lot of stuff. Alright, ready?
Let's not make those.
That's gonna have the same problem on it.
Over n.
Will it not? Oh, okay.
Okay.
There we go.
There we go, Jeff.
Now we're making it happen.
Be quiet. So. What's interesting, I kind of don't mind this because you guys hopefully can start to see, if you're to the point where you can start to understand how do you construct your problem is going to do something you want it to do, that means you really understand what's happening. Which makes you wonder why it took me 3 tries, but okay. I'm telling on myself. So 3 to the n plus 1 times x minus 4 to the n plus 1 over n plus 1 times reciprocal, right? 3 to the n, x minus 4 to the n. So I lose n of these, I lose n of these. So far I've got 3x minus 4, and then I've got n over n plus 1. Look at that, yay. Okay. Good Lord, Jeff. That's what I want, that's right. Okay, that's right. So this equals, what's this limit of course? 1. So we get 3x minus 4, and that has to be less than 1. So here's where you gotta be careful when you have a shifted function like this, right?
Okay.
So I'm gonna divide by 3. Now I can see the radius, and I can see the center. I really want you guys to see this. So this says I want the distance between x and 4 to be less than 1/3. So I want to go 1/3 out from 4. So isn't 4 my center? We all know absolute value means distance. The distance from the number to 4 has to be less than 1/3. So I want to start at 4 and go up 1/3 and down 1/3. So 4 is my center. My radius of convergence is 1/3. But now I have to solve this. So I get negative 1/3 less than x minus 4 less than 1/3. Add 4 everywhere. So I get, what is that, 11/3? 13/3? Is that right? Thank you. Yes.
Is this a sign switch again? That's when it's
Sign switch? What do you mean?
like when you have an inequality.
So real quick, when I teach students about less than inequalities, it's basically all we're going to have here. The greater than inequalities I call a restraining order. So I want the distance between you and me to be at least something. So stay the shit away from me. So that's when you get a set over here and a set over there. You get like negative infinity up to 3 or 7 to infinity or something. Stay away from me, right? Less than is going into a haunted house. Stay close to me, right? I've watched all the horror movies. Let's stay together. Stay close to me. Why are we even going here? I don't know. Try to find the clown and do some weird stuff. Okay. I'll float it. All right. So, and just think about it. x can't be 3, correct? And it also can't be negative 3. But it could be 1, and it could be negative 1, right? So it just can't get more than 2 away from 0. Again, absolute value means distance. So this means the distance between x and 0, oh shit, is at most 2, or is less than 2. So it can either go up to 2, or it can go down to negative 2. Stay close to it. Maybe. So you can always interpret absolute value less than a number as negative number, less than stuff, less than number. So that's what I did here. Absolute value stuff less than a number, negative number less than stuff, less than that, and less than number. I can get 1/3 up, 1/3 down. Is that okay? Okay, so that's the ultra truncated version of that lecture. What do I have to do now? Am I done? It looks like I'm done.
You have to check the end.
Oh, shit. Okay. So, I'm going to erase this because we got the answer basically. We just need to know what happens at the endpoints. Now that I finally made one that has endpoints. What does this series look like for 11/3? What is 11/3 minus 4?
Negative 2/3, or yeah,
Negative 1/3.
Negative 1/3. Oh, so close.
Now this looks a lot like the one we just did. What is 3 times negative 1/3? I have n of these and n of those, so I can just multiply all the 3's by all the negative 1/3, so I get n what's? Negative 1's. Is that convergent?
Yes.
It's a convergent alternating series, right? Okay, I'm going to start to become a little more lax on this, but this is pretty obviously, if I do alternating series test, the limit is 0, and it's positive, and it's decreasing, blah, blah, blah. So this will be included, so I'm going to include 11/3, because it makes it into a convergent series. Can somebody see already what's going to happen with 13/3? 13/3 minus 4 is positive 1/3. Positive 1/3 times 3 is 1. I'll end up with what series?
Harmonic.
Harmonic, because does everybody see that? 13/3 minus 4, 1/3 times 3 is 1 to the n, is 1 over n, is harmonic, so I'm not going to include 13/3. Shebang. So that is the interval of convergence, and that is the radius of convergence. How do you check the radius? Well, how far apart are these?
You add them together, you divide by 2.
Or just subtract
2/3.
2/3. Yeah. That's the diameter, right? It's all the way across, so it's the radius.
1/3.
Yeah. So you can kind of check your answer. Some of these doctors like, go, Jeff, go. Look at you, adding things. All right. Okay. Blah 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 blah. Okay. So now, let me go ahead and give you this. Yeah, I'll give you this. This sheet is a little funny to me, but that's okay, because one side of it is 11/10. Maybe don't look that side too much yet. But I'm just giving it to you now. We are going to talk about 11/9. I just didn't want to make a sheet for it, apparently. Yours is in there. Take care of everybody over there. What happened? Everybody okay? What? Something happened over there. She dropped something. Oh.
Taylor polynomial.
Leave Taylor alone.
F can be differentiated with n times a when defined n.
Focus on the side that talks about section 11.8, not 11.10. So basically, I just kind of talk about the parts of this. I give you a couple examples. I use the same example, the 1/5, because I'm not very creative. And then there's a fundamental problem. So for which values of x does it converge? And that's what led us here. So let's kind of lead you through this. There's a theorem there. So those are the 3 things I was going to write on the board earlier. Either it only converges when the thing I'm looking at is 0. So if it's in the form blah, 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 it will definitely converge when x is 0. I don't have to do a damn thing to know that. If x is 0, I'm adding 0, that converges. Whereas if it's this, what will that definitely converge for if x is
-7.
-7? Whatever makes it 0, I'll be adding 0 to itself forever. So that's one possibility. That's called the trivial solution. Make it 0, of course it works, right? Or it could be convergent for everything, right? That's the negative infinity to infinity that we saw maybe a couple of examples of, right? That's when the x dependence goes away. Or it could be something like this, like an actual interval that only works for certain values, right? So not just one value, it works for infinite values, but they're contained between two finite numbers. It's pretty okay with what I just said, because of course, how many numbers are in this interval?
Infinite.
Infinite number, okay. They're just contained by finite numbers. Okay. Blah, 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 blah. And in bold and red, I put we must check the endpoints, because people often forget that. Because your brain says, oh, I got an answer, I'm done, but you gotta check the endpoints. Okay. Blah, 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 blah. And then I say we often use the ratio test, but like we saw tonight, we can use the root test sometimes. So why don't you guys try number, which one's interesting? Yeah, try 3 and 4 real quick. 1 and 2 are boring. Try 3 and 4. Zero. Jeff. Oh, I forgot about him. Darn it. Why did gonna start doing number 3 here. I'm not used to having such great markers, holy shit. Let's do this one.
There's like 20 of them down there.
Yeah, most of them are dead. Alright, so similar things happen, right? I lose n x's, I lose n 3's. Alright, so far I've got x over 3, and then I got this n plus 1 over n plus 2. As n goes to infinity, this goes to
1.
1. So I get this, which must be less than 1. So then I multiply. Good. So now my radius of convergence is 3. And my interval of convergence is this. I just don't know about the endpoints yet, right? Okay, so if I let x be, let's start with, it doesn't matter, Jeff. If x is negative 3, I'll get negative 1 to the n, negative 3 to the n, over 3 to the n, right? N plus 1. All this does what?
Cancels.
Cancels. Negative 1 to the n, and then is 3 to the n, divided by 3 to the n, this cancels.
Mhm.
So I'm left with what is essentially harmonic divergent. But if x is 3, good lord, Jeff. I get negative 1 to the n, 3 to the n, over 3 to the n. Jeff, you can do it, buddy. Yeah, okay. N plus 1. They cancel. This is what kind of series? Alternating. Limit 0, positive, decreasing. So this converges. You would just state those things. That's pretty obvious for this one. So what's the actual answer look like?
Parentheses negative 3 square x. Oh, square bracket.
Bracket? Yeah,
Bracket. Yeah. Alright. There you
Stay with me.
go. I'm here.
Okay.
I want dinner.
All right. Not too bad. Is this? I mean, this is just adding a couple steps on the end of a ratio or root test, right? Now this step could get gross depending on what you get when you right. I mean, this step could be kind of involved in itself. It could require almost any test, depending on what the series looks like to give us.
Yay!
So that's one of the calculus teacher's favorite problems is something that requires multiple things. I'm really giving myself any room. This guy, I don't know, have you guys probably haven't had a chance to look at that one yet? Haven't you?
Yeah. I got started.
It's not too bad. It's pretty quick. I believe. So, there's infinity. 5 to the n plus 1 over n plus 1 squared times n squared over x minus 5 to the n. I lose n of those. N squared over n plus 1 squared times x minus 5.
That one was
I didn't mean to cross that whole thing up. This goes to
1.
1, so then x minus 5 just has to be less than, oops, how should I? Less than 1.
So we have 6 and 4.
Yeah, so the radius is 1. And if you understand, like you just said, if you understand what this is saying, the distance from 5 is 1, well then it's 4 to 6. Or you can put this in between -1, add 5 to all sides, and you get 4 to 6. Okay, was that too fast? Are you guys good? That one's a relatively easy example, right? If I put a 4 in, if I put a 4 or a 6 in, why does it not matter if it's alternating or not? I get a constant over n squared. It is a
P-series.
P-series, where P is greater than 1. You guys see that? Now again, you'd have to at least state that, right? But if you just said, either 4 or 6 makes it a P-series, Jeff. P equals 2 greater than 1. Beautiful. What does that mean the answer should look like?
Equal to, or greater than or equal to.
Yeah,
bracket 4, bracket 6.
Bracket 6.
Yep.
Or we can-
That one was super easy.
But it's nice.
Yeah.
It's shifted. It's got a different center. What's the radius of convergence?
5.
No.
Oh, radius? 1.
1. Yeah. So as long as you get the multipliers or dividers away, what's left is the radius right here. And that's how far you get away from the center, which is 5. And of course, you can always just see the radius here. Yes?
How would you write CN?
Yeah, so what's Cn for this? Basically Cn, you just cover x to the n.
Like for 4.
Oh, 4, I'm sorry. Yeah, what's Cn here? 1 over n squared, yeah. So in general, this is a special case where A is 0. Here, A is 5, or -5. Put an x plus A. I think normally it's x minus A. Okay, so we can talk about power series centered at something. This is a power series centered at 5. This is a power series centered at 0. Okay, I love it. Because before we did any work, what did we know works here? 0. What did we know works here? 5. It's just a question about, can I get away from 5 at all and it still works? That's the question. That's why we call it the radius of convergence. Can you get away from 5 and it still works? Yes! What about over here? I can't, we're there, yeah. Yes, we can get away from 0, a little further away from 0 and it still works. Are you guys feeling that? Are you guys getting that? Okay. This to me is some of the coolest shit. Okay. Especially because I know what we're going to do next with this stuff, but not quite yet. Last thing for today, two things. If you have the book, page 748's got something interesting. I was going to look for something. Let me see if I can do it.
I see a weird shape.
See a weird shape.
748.
If you want, you don't have to look at it. I'm going to try to show you. I'm going to go to the YouTubes on the internet. I don't know if you've heard of the YouTubes. She got all kinds of videos on there. All right, let's see. Here's some. Let's go on this.
Best functions.
Let me see if this gets me what I want. Yeah, let's see. It's just, yeah, look at that shit. Oh, it's perfect. Okay. Beautiful, beautiful. Let's turn the volume down. I'm turning the volume down, but it says I'm turning it up. That's concerning. Okay, let me just turn the volume down on the computer.
Here,
That sounds dangerous to me.
Yeah.
Right,
Yeah.
That's like that nuclear meltdown.
right, this room obviously has some issues. I turn it on, what's happening? All right, I just want to show you this real quick. This is what I wanted to do. That's already not going to be true.
Should I point the camera?
Say again?
Should I point the camera?
No, because then it's probably copyrighted. I made that mistake before. As opposed to these YouTube's like, hey, oh shit. So you guys, okay, this is the surface of a speaker, basically. It's kind of like a constructed speaker. Do you see the various configurations that surface is making as they change the frequency of the sound? So if any of you, are any of you into like bass and big ass speakers in your car? I have no idea. Or have you ever seen that kind of fascination?
Yeah.
My subwoofers?
So there's a bit of a fascination with it. And if you get those big ass speakers with the membrane, if you record it, this is obviously very slow motion. But do you see how the surface is jiggling around? Obviously, right? And different frequencies cause it to jiggle differently. Okay. Okay.
Four regions.
There is an equation of motion for this. One solution of which, well, shit. Yeah. All right, here we go. Oh man, multimedia. I can't take
13
it.
years ago, wow.
Is it 13 years ago? Oh yeah. Back when YouTube didn't know what it was yet. Okay.
Where is that? Oh, yeah.
Oh God. I love this room.
That's rough.
Same.
What you're not seeing is, here we go, it's up here. This is not weird to us, right? On one level, this series is just a series. That's the series you would expect to get from me, correct? It's got a little bit more going on than the ones we looked at, but it's pretty basic. That is the solution. It's not really directly connected to the membrane thing. It's sort of inverse. Do you see how this is of order 0? This is a Bessel function of order 0. So that kind of implies there's a Bessel function of order 1, a Bessel function of order 2. Or is there Bessel functions of order fractions? Yeah, okay. Oh shit. Right. So this is a little bit beyond this. If you're going to take differential equations, this comes back. So I was talking to people before class started. There are integrals we can't do, correct?
Like ever?
Yeah, we can't do by hand at all. And we can never get the exact solution for them. The most classical one, the most often referred to one, is this guy. There's no way to do that by hand. You can only ever get numerical approximations. The solution, though, there is a solution to this. It's in a series form. So when you take diffie-q, if you do, I don't know, does anybody here have to take diffie-q?
Is that
Differential
up 3?
equations?
No.
I love it. All this series shit's gonna come back. Not as the whole class, it's gonna be a part of the class. But it's gonna be a very important part of the class because I wanna know how to integrate these non-integratable things. I wanna do it. So we did to a certain degree. That doesn't give me an answer though. So what I wanna do right now, looking at that, and I know, well, that I could have recorded, but it's okay. You guys, okay. In fact, I'll put it up here on the board, and I'll turn the lights on.
When you say we can't do it by hand, do you mean like because there's like a time constraint?
No.
It would take, or you mean we just can't even try?
There's no method to do this integral and get a functional answer.
Oh wow.
Plus C. So there's no way. Right. I really want that understood.
Well, we have one part down, obviously.
Yeah.
We got the plus C already.
Yeah,
We got the plus C down. We
that's
got
half
that.
the battle right there.
So, real quick. Shoot, I took it over. Damn it. Okay. Let me write it up on the board. I want to do something real quick, and then I want to do something else. It's already 7 o'clock, and it's, oh well, Jeff, you got time. Yeah. So the Bessel function over order 0. Did they put the little 0 there? Yes.
We don't need this in our notes, do we?
Yeah.
We do?
Yeah, we do. Yeah, we don't.
If I were you, I'd put it in my notes.
Okay.
In fact, let me put this down correctly first.
Hey, man.
What, are you already packed up? Is that what it is? Okay.
Open my eyes on.
Real quick, we haven't done this yet. I might as well try to do this now. Can we write the first, and let me make sure, it actually starts at 0. So a lot of these do start at 0, so be really careful about what the end starts at. So they're gonna kind of alternate sometimes. So help me out. When n is 0, can somebody tell me what we get? -1 to the 0 is positive. X to the 0 is 1, right? 2 to the 0 is 1. 0 factorial is 1, so I get 1, correct?
Yeah.
Yay, Bessel function. Okay. What do I get when n is 1? I'll get a negative, right?
Yeah.
Minus. I'll get an x squared, yes?
Mm-hmm.
I'm gonna leave room so I can write the coefficient here. Actually, it'll be 1 top of 2 to the first, 2 squared, 4, and then 1 factorial is 1 squared is 1, so I get this. When n is 2, it'll now be plus, right? -1 squared is positive. X to the 4th over 2 to the 4th, which is 16, times 2 factorial, which is 2 squared is 4, so I'll get x to the 4th over 64.
Okay.
Minus, and then it just keeps going, yes? We'll stop there.
Okay.
But I want you to realize, what is that? Mathematically, what is it that I've just started to write?
A series?
Just, no, well, it's a series, but have you seen that, would you have seen this in pre-calculus? Would you have seen this in algebra?
Yeah.
What would you have called it?
A polynomial?
Freaking polynomial, that's all it is. But it's the solution,
It's reverse poly.
and in this case, this one specifically is a solution to Kepler's planetary motion equations, right? It was his equation for planetary motion, which are really freaking cool. This is, and then if you use different orders and if you adjust it by a little bit, it actually becomes a solution to the membrane's equation of motion. It's really funky. Okay. But I just want to show you every one we've done so far, they have all been polynomials. Okay. There's one thing we've done. This is my lead into section 11.9. There's one thing we've done already that is basically a polynomial, and I kind of gave it away earlier. We did this before, right? So let's be smarter about it. Screw you. Let's call it x to the n. And so we know quite a bit about it. So tell me out, what does this look like if I write a few elements out?
X plus x
Actually,
squared.
let me make it 0.
Okay, 1 plus x plus x squared. Plus x squared.
Ricardo's like, come on, man. I was in there. I was ready. Just buzz the buzzer. All right. But here's what's interesting. If the value of x I choose is less than 1 absolute value, does anyone remember what is this equal to? Do you remember? I mean, remember when we had geometric series? And you had to figure out the s? Wasn't it a over?
A 1 minus r?
Okay, good. What is a?
Y.
The first element, which is 1. Over 1 minus, and what is acting as r? X. That, okay,
Where have I seen
hey,
it?
okay, everybody, just stop for a second. This is our first example of a function, 1 over 1 minus x, that can be written as an infinite polynomial. We've actually done this already, we just didn't identify it as such. This is a function of x, yes? It can be written as an infinite polynomial. Now, to be honest, is this function really difficult to work with?
Yeah.
Okay.
Well,
sorry.
because I don't know.
All right.
It is.
It's not that difficult, right? So, in the next section, we're going to talk about, okay, what if I have a different function? Can I make an infinite polynomial that represents that function, and then can I figure out the radius of convergence for that? Yes, we can. It's going to be awesome. We're going to figure out e to the x. What does its infinite polynomial look like? Sine x. What does its infinite polynomial look like? Yes. Yes.
So if that equals like 1 over 1 minus x, can you square that and then
Okay.
square the series and then
Totally. Well, let's not do something quite that funkadelic.
Okay.
Right? Because that's a bit much.
Yeah.
That's a good way to
So,
get e to the x
let me
squared.
ask you this. So this is kind of like the way I like to kind of break it in. Is everybody with this? This is just geometric. Instead of r's, I put x's. That's all we've done. But now we're starting to identify it as this is a function of x that we have said equals this if x is less than 1, right? Absolute value. Okay, so if x was 3, this ain't true, right? So it does have restrictions on it, which you should expect.
Can't the sum be infinite though? Because x can be infinitesimally like as close to 1 as possible.
Of course, but it is, if x is less than 1, this is convergent. Period.
Okay.
Yeah. I like it. Okay, so what is this guy's derivative?
Natural log.
Let's see, where can I put this? Let me put it right here. What is this guy's derivative?
Natural log of 1 minus x.
You are integrating it. I love
Oh.
you guys. Plus x squared. I love you guys so much.
1 over 1 plus x squared.
So let's write this a little bit differently.
Negative 1 to times 1 minus x.
I'm so
to the
hungry.
negative
I don't know why I'm never this hungry.
Times
during
negative
class.
1. There we go.
So it's 1 over 1 minus x squared, right?
Yeah.
Well, if I took the derivative of this side, can't I take the derivative of this side? What's the
Yeah.
derivative of this side?
0 plus 1 plus 2x
Yeah.
plus 3x squared plus 4x cubed, etc., etc.
So we can build, if I know the power series representation for a function, everything I can do to that function I can also do to its power series. In fact, let's do this one better. Let's just freaking differentiate this thing. Because that is this, isn't it? Was it hard to differentiate this? No. So it cannot be hard to differentiate this at all. It can't. There's one little thing you have to be careful of. And I'll show you one. So how do you differentiate this?
Drop down the n, and then it.
N minus 1.
Yeah. And then
Can I start at 0 now? That wouldn't make any sense, would it? So anytime you take the derivative of a power series, you basically, didn't we lose? Didn't this go to 0? This is kind of a way to remember this. It's not why, but we lost one, so this should start at 1 now. Another way, if this was 0, would this be 1 over x? Do I have a 1 over x? No.
No.
Does this match this? If n is 1, this is x to the 0, it's 1. If n is 2, this is 2x to the first. Hey, if this is 3, this is 3x squared. Hey, if this is 4, maybe you guys see that? I mean, to me, no, please, I don't know if I'm not presenting this correctly. This is freaking huge. This is monumentous. And I know you might not fully be able to realize this. Because this is sort of old. Part of this is old, but I can do something very similar for almost any function. I can figure out what its polynomial looks like, what its infinite polynomial looks like. So for example, real quick, I can figure out e to the x squared. I can make that into a polynomial. Can I integrate this? No. Can I integrate a polynomial?
Yeah.
Shit, yeah. So all of a sudden, I'm able to freaking integrate it, however long I want to go.
So you just find the infinite polynomial for ex
And then
squared.
do what I need to it.
Can you integrate that?
Of course.
And then is that how you find an integral for ex
Yes.
squared?
But again, you can't get the exact answer because you'd have to go
You just have to get
infinitely many points. But
real
you can
close.
get so close to the same end that it's basically the same thing.
Yeah.
But you can't get a closed form for it. Do you guys know what I mean by closed form? Like derivative of sine x is cosine x, closed form. It's not infinite. The integral of e to the x squared is infinite polynomial. Shit, there's no closed kind of form. There's no functional answer. It's a series, right? Okay, maybe. I'm sorry. Who got a question? I skipped over. So yes.
Is that what the common and common is?
Say it again.
The comment that you have on your paper for the grade.
Oh, for the homework?
Or the.
Oh.
I think it's the.
Oh, I thought you said something about Calvin and Hobbes. I was gonna joke that, and you actually did. I can't remember which one I put on there. I don't think it's related to. Oh, it'd be really interesting.
You have a different one.
I don't have it on me.
That isn't Calvin and Hobbes. That does a sequence for sine of x.
Oh, that's right. It was Foxtrot.
Yeah,
It's Foxtrot, yeah. And that they're using. Thank you. Beautiful. They are using the sine of x, the infinite polynomial for it.
To find like what?
Yeah,
a
because he's
half-
getting paid by the whatever.
the hour.
So he's just given the infinite polynomial answer, you know, and so, yeah. So look at that. Thank you. Forgot about it.
Are you talking about the meme? Like the.
Not a
I was
meme, it's a
conf-
comic
I
strip.
know.
It's
I-
on
You
the
brain rotted zoomer.
on the homework sheet, I think.
I was so confused what you guys are talking about
It's
right
the
now.
comic
Okay.
that's at the
I know
bottom.
exactly what you're talking about.
All right.
I thought I like missed something like.
That was
all right.
the most brain
Guys.
rot thing I've ever heard in my life.
Guys, last thing for today, we'll head out. If I gave you, let's see, what you got? Yeah, let's just get this. Can't write anymore. Sure, that's fine. Can you take this guy's derivative?
don't know how to take a derivative of factorial, but if you found the other thing.
Now listen,
yeah.
listen. What am I taking the derivative with respect to, of course?
X.
I don't see x factorial in there at all. So
Oh.
everything else in there is a constant,
Right.
as far as x is concerned. And factorial, constant.
How's that possible? That changes.
No, but it doesn't. Just ignore that for now.
Two,
What do you mean?
2x to the
Well, I
n
mean,
over
it,
n
like, it,
factorial?
like iterates. It's like 1, 2, 3, 4, right?
Sorry again?
2nx.
Yeah, so the 2n comes down,
Okay.
Over n factorial.
x to the
2n minus 1.
To the n?
2n minus 1.
Oh, okay.
Right, that rule doesn't change. Power comes down, it goes down by 1. Over n factorial, that doesn't change, it's just a constant, just comes for the ride. But now n has to start at 1. So let's check this real quick. What are the terms of this? Just give me a few terms. What's the first term?
Why does it have to start at 1?
Yeah, I don't know.
What do you mean? Sorry.
Why does, why does that start at 1 now?
If n is 0, don't I get x to the negative 1?
Yeah, what's
That's
wrong
not a
with
part of it. Plus, I lose, whenever I take the derivative, I lose the first term. The first term basically becomes 0. So if I try to make n start at 0, that term I lost. Didn't I lose a term when I took a derivative? So if I have 4 plus 5x minus 7x squared, how many terms do I have?
3.
If I take its derivative, don't I have 2 terms now?
Yeah.
So if I try to pretend like you can go backwards, it'll assume it's like something over x.
Okay.
Because it's got to kind of look at the pattern and go backwards. So if I try to make n 0, don't I get 1 over x here?
Yeah.
Okay, that's why.
Yeah.
Is that better?
Yeah.
I just made that up now and never explained it like that before, and I like that. So, okay. Real quick. What's the next term?
X squared.
X squared over 1 factorial, so x squared.
X to the 4th.
X to the
2.
4th over, good, 2 factorial, 2. X to the 6 over,
6.
yeah, 2 times 3, 6, I like it. Dot, dot, dot. If I take this derivative, don't I get 2x, right? Plus? Yeah, 4 comes down,
2x cubed.
2x cubed. Plus? 6 comes down,
Fifth.
cancels, x to the 5th. Let's see if that matches. If n is 1, I get 2 x, bang, right? If n is 2, I get 4 x to the 3rd over, what did I just say? 2. 4 x to the 3rd over 2, that's 2x cubed. Right? And if n is 3, I get 6 x to the 5th over 6 x to the 5th. So forth, right? So I don't know how you feel at the moment about taking a derivative of a series. It really is, it's beautiful. I have an infinite number of terms here. We just did the derivative of an infinite number of terms in one step. I really want you to understand that. Infinite polynomial terms, holy shit. They ain't kidding when they say poly. Fudge, right? And we just did it, bam, one step. Infinite number of things. Good job, everybody. That's plenty, I think. So next time, we'll finish up chapter 11. I'll have the practice test. We'll take a quiz, right? Wednesday is review day. Sorry, yes.
When's the real test?
When's the actual test?
14th?
Yes, Monday the 14th. Monday the 14th. So I lost a day, but we're actually still on track because we were actually a little ahead. So that'll be good.
2 Mondays.
Uh,
The following Monday after that.
after
this
upcoming one.
Yeah, a week from this coming Monday. is the
Okay.
test, yeah.
We cover parametric and polar functions pretty quickly then.
Yes, relatively. Hopefully you did some of that in your pre-calc.
We're gonna have to. Should if we like if we
I didn't do it in my pre-calc, but I did it in my regular calc.
Oh, okay.
I don't think I did parametric in my calculus.
if we
It is
while
part
our-
of our pre-calc too.
Oh, yeah.
I asked you, what is
If like in pre-calc we didn't get parametric at all, should we shore up on that before we start the chapter?
I'm gonna do a review.
Okay.
I'm gonna assume there's some people that, maybe it's been a while.
Yeah, we got it during COVID, so.
Understood. I
President.
also assumed the COVID thing too.
Yeah.
Yeah.
See, Kellen?
Hi, Professor.
Well, I'm gonna stop that for you.